In a previous angle with trigonometry, degrees, and radians, we talked about the relationship between the central angle, the arc length, and the sector area, and I mentioned we would talk about it later, and here we are. So first, some general stuff about circles. You know the radius is the connection between the center of the circle and an outside point. The diameter is just 2 times the radius, so it's the chord or the segment that goes through the center on both sides of the circle. That's your diameter. Here are the formulas for area and circumference, which are given to you in the front. And as we also mentioned, this is given to you in the front as well. So what did we establish last time? So when you've got a circle with a sector, and this thing is called a sector, it's a piece of the circle that's been cut off by this central angle, which we will call x. Now here's the thing. This whole circle, we'll use degrees because that's easier to think about, has got 360 degrees in the middle of it. So this x is some fraction of that whole 360. In other words, it is x over 3/60th of the entire circle. And this tells us not only what fraction of the entire circle this central angle represents, it tells us what fraction of the whole circumference the arc length represents, and what fraction of the area this sector represents of the whole total circle area. So we can use all of these things. They're all related based on this fraction. So how would this work? In a circle with center O, central angle AOB has a measure of 2 pi over 3 radians. The arc length of the arc formed by central angle AOB is what fraction of the circumference of the circle. So we want to know what fraction this arc length is of the whole. We know that this angle is 2 pi over 3. So we can figure out, all right, if this is 2 pi over 3, what fraction of the whole central angle is this? And whatever that fraction is, it's going to be the fraction the arc length is of the entire circle. So what can we do? Well, the first thing I recommend is let's turn this to degrees, just because I don't want to deal with radians. You could do this with radians, but it's just easier to work with degrees. It's a bit more intuitive. So we multiply this by 180 over pi. Pi's cancel, 60s cancel. We get 120. So now we ask ourselves, okay, what fraction of the whole circle is 120 out of 360, right? 120 out of 360, that just ends up being 1/3. So this is 1/3 of the whole circle. So this arc would be 1/3 of the circumference. And if we cared, this sector area would be 1/3 of the whole area. Let's try this one. In circle O above, the radius R is 20. If the sector area is between 50 pi and 60 pi, what is one possible integer value of x? Very interesting. So we know the area of this thing is between 50 and 60 pi. We know the radius of this is r. So the first thing we can figure out, let's find the area, the total area of the circle, which is pi r squared, which is pi times 20 squared, which is 400 pi. So here's the thing. If this is 50 to 60 pi, then we know that on the low end, this sector is 50 pi over 400 pi of the circle, right? It's that fraction of the circle. And on the upper end, it's 60 pi out of 400 pi. So let's see what these fractions actually are. The pi's cancel out of 10. So we get 1/8 of the circle on the low end. This is not going to work as well, but let's see. 6 into 40, cancel out of 2, so we get 3/20. So our circle, our sector, is between 1/8 and 3/20 of the area of the circle, which means this central angle is between 1/8 and 3/20 of the whole central angle. So what we can now do is multiply 1/8 times 360, and that would get us 45. And then 3/20 times 360, which would get us 54. So these are the bounds of our angles, right? On the low end, it's 45. On the upper end, it's 54. So any number between 45 and 54 would be an acceptable answer here. So anything between 45 and 54. You can't put 45 and 54 because those are our boundaries, but you could do 46, you could do 47, 48, all the way up to 53. So really, let me change that. Anything between 46 and 53 would be the answer. I mean, you could also write it like this. It's the same. But any integer, remember, because it's got to be an integer. So an integer is a non-decimal fraction. Any integer between 45 and 54, in other words, from 46 to 53, would work.